All right, so here's an example of the try this activity, which I believe is number 4.19 in your study guide. So we're doing Punnett squares in this one, and I believe it's talking about the disease sickle cell anemia. So sickle cell anemia basically affects the shape of your red blood cells. It is also a recessive disease, so that means that it would be given the lowercase letter, and a normal gene would be the uppercase letter. So we have three options for people. Remember, we always have 2 letters per genotype. So if a person has 2 big A's, the big A represents the dominant normal gene. So this person is completely 100% healthy and normal when it comes to their blood cells. If you have a big A and a little a, this little a represents the sickle cell anemia gene. However, since the big A is dominant, you do not have the disease. You would be what we would call a carrier. So that means while you don't demonstrate the disease yourself, you do have the possibility of passing it along to a child. Sorry about the focus. All right, and the last option is you can have 2 small a's. If you have 2 small a's, that means that you have sickle cell anemia. So the only way you actually get the disease is if you end up with a recessive gene from mom and a recessive gene from A. So I'm going to do an example. I think the first one suggests that the first parent is completely normal and the second parent is a carrier. So I'm going to show you how to do that. So we do a little square like this. In a Punnett square, we have 1 parent across the top, getting 1 letter per block because these letters will split. Think of it in genetics that half your DNA comes from your mom, half comes from your dad. So I'd have 1 parent across the top, and the second parent I'm going to put along the side. These 4 squares represent the children. So I'm going to take this parent, and they get 1 big A, 2 big A. This parent here, big A, little a. All right, so now that I have my parents, these represent the kids. So they get 1 gene from their mom, 1 gene from their dad. So I'm taking 1 from above, 1 from the side. 1 from above, 1 from the side. Now here, 1 from above, 1 from the side. So you can see that child has a big A and a little a. And again, 1 from mom, 1 from dad. So when I look at my 4 children, 1, 2, 3, 4, 2 of them are completely normal. 2 of them are carriers. So the question asks, what is the chance of any of the children having a disease? So in the case of A, since we do not have any offspring that actually show the disease, my chances would be 0%. Or you could write it as 0 out of 4. So if you get 1 out of 4, it'll be 25%, 2 out of 4, 50%, and so forth. Okay, so this is A completed. And you'll find that with B and C, you'll get a little bit more of an interesting result. You may have an offspring or 2 that has 2 small a's and therefore would have sickle cell anemia. Hopefully that helps.